Welcome to Wickerson Studios. Michael Wickerson here. I have decided to try and field a couple of questions I've been getting online. Obviously, my interest in my videos, I like to go as far as I can, take my mind in so many different ways, usually programming. But I thought maybe return to the basics through a very practical means for those starting Grasshopper for the first time. So if there's an interest in this, I will break these down into tutorials. Otherwise, I'll just offer the files out and you can play with and see what I have. Basically, the best way to start, I think, with Rhino and Grasshopper is to have a reference image. So what I've done here is I've gathered up a little bit of information about the Parthenon, who it was made by, what's its style. I did have its size and scale, but in the end, the best thing to do is import an image, scale that image, center the reference image, and set that layer and make transparent and lock. And I can do that if people are absolute beginners. And we take a look that I have a reference image that I can't touch that shows me kind of the scale and where I want to begin the Parthenon. The only thing I've made from the right and front view and the top view and the perspective view are the stairs. But I think the trick is bring in your image, find its center point, bring out the data you need, the points, the surfaces, call them breps if you want, curves around the edges, and the points, which would be the vertices from that as well by deconstructing the brep, and then take those points and have relay points to get back to data, and then set that point, have a plane and a plane origin you can start from. And I've used hidden wires. So basically, I'm going to produce the steps to start. What I'll end up doing after that is producing the end columns, the Doric columns, the Intasia, maybe this statue. I'll import some images. It's nice to have reference and scale because then you can start bringing things into this temple. But how would you script it so you could think about the kind of complex geometries involved in something as simple as the steps of the Parthenon? This is not a simple assignment. If you take a look at this, you'll see that it's iterative in a sense, even though I'm not using hoop, snake, or anemone, or Python or C# for that matter. There is a very subtlety that they're concave. So let's take a look at what happens on these steps. The steps have a curved profile. So you've got to make that curved profile. It rises towards the center, and it bows out a little bit in my model. And it also, the treads are set within a slight upward tilt. So this is not level. So these are complex stairs. The device of perspective correction produces a complex geometry for construction. So let's start with that middle plane and take that plane and take the curves that are coming out of the exploded brep. There's another hidden line over to the plane, and there's a hidden wire over to the curves coming out of deconstructing that brep reference image. Everything is interconnected. And what you can do is taking a look at this, I'll just show you what the script does. It basically allows me to scale out the stairs on the X level, scale out the Y stairs on the Y level. It's not iterative past 3 because I really only need 3 steps for the Acropolis. 1, 2, 3, 4, 5. No, I probably need more. 5, 6. I'll have to add some more afterwards, and I'll show you the clumsy visual way of doing that in Grasshopper. And you won't need Python. You won't need any coding to do that. You can just do it, and you won't need any special plugins. The other thing you can do is you can scale those steps up and down, so you see you get the bevel on the steps going steeper and tilted towards the center more. Keep in mind that the front and right are parallel, so you're seeing that steeper step. It doesn't have to be that grand, but I guess I'll exaggerate things right now in the right. And then the other thing you want to have effect on is controlling that concave. And there's so many ways to control that concave nature of the stairs themselves, the curve. They hardly have to be like that. They just have to be a very subtle way of looking at it. But I produced an arc on the profile curves that actually are pretty cool because they do work all the way around all the sides. So you get this very complex geometry with this ability to lower and flatten the steps and also make that concave, play with that concave. So the script itself is fairly straightforward. I've kept everything to a unit vector, to a unit 1, and multiplying and keeping the scale factor. And what you end up writing is the loft through the top step and the curve. So the top step's here. You see that here as well in the right, and you can see it highlighted around the top view right here. And then you're basically going to have that outputted loft, and you're going to use the data that's driving that. I put these in blocks for the first step, which is not technically the most efficient way to write. You'd want to write this through a range and control your data trees and structures, but this is probably the best way to visualize what has to happen in an iterative manner and what data then drives the next one and the next one. The next thing I do is I actually have a more complex script breaking up, but once again, not using too much complexities, visualizing, creeping around the edge of that. You'll see right here, possibly on the top view, that I can creep around, and maybe I'll just take my selected tool to something really bright and red. That should come up red now. I'll bring it to opacity red. It's kind of a warning. So as I select that, you'll see that I have that red line and this red line, which is the curve, and this one over here on the other side, and this one. So basically, I'm able to grab those segments and still use them as kind of tree data as I go through. And I take that whole process and iterate it again as a next step by grabbing the loft for the beveled staircase going down, and then the edges to that. So you can see all four edges selected there. Actually, you have to select right to left, and there they are. And then I do the same thing for the last one, pulling that iterative again. And this is just really for the beginner trying to understand Grasshopper without getting too much into the complexities of tree data using lists as opposed to that. And I don't have to push this into a tree structure. Not saying it isn't interesting to do that, but to start your models and to have a sense of what's being built and make some more complex geometries, kind of like thinking of simple addition and multiplication, you can write and have access to a pretty visual script that if you actually think of the visuals of what's happening in this model as a sense of data and what's driving this Acropolis, we're going to do some really nice masking and set tools in trees to understand these columns as we start to make them. But to be able to build a kind of loop that if you needed a next set of stairs without having to go iterative throughout it, you could copy the whole system. You could output the data that's required here. I'll just show you here. This data, I believe these curves are the ones that have to feed the next geometries over here to build another one. And then the other data that has to come out is I'm going to want, one thing about this is I can't stand these groups on here because they make for complexity. I'm just going to go in here and take a look at what was happening on group. That the other data that has to come through is this geometry serves the next one. And if I think back, this geometry serves this geometry. So I have to go back to mimicking what I just did. The join curves right here, over to here, this one over to here, and let me just think of how I've made that as the geometries come down. This geometry does not want to feed back to that initial one. This geometry here, which is a move tool, actually has to feed back to, let me just think, right back to, this is always a little tricky, that one feeds back. This one feeds back. Oh, hang on a second. Just building another step is quite simple. If you wanted to do more on this one, and I have a tendency to like baby blue to make me feel like I've done something right. So basically the same thing. If I needed another step, I could grab the whole system, I could bring it down, and I'm simply gathering the data from, if you take a look, from this data source and feeding the next one. So I can output that move, bring it in here, and I get a whole other step. And you just keep going, and it kind of scales out, and you can get on your 5 or 6 steps of the Parthenon, whatever you need to do. Now, in time, you'd want to learn how to work repetitively and run that through so you're not cutting and pasting script, but it's okay to do for a starter. It does let you visualize things and think about what kind of scripts can actually, what these scripts can do for yourself. But we've got the steps of the Parthenon. We've got the ability to take a look at them on this level, which is kind of nice. I'm just going to bring this one over. and we have the effects of a very simple bevel and multiplication. If I want to shrink that or bow that out or pull that arch out, and I also can lower and raise that bevel of the stairs coming down. So I have more complex geometry than you might initially think. It's actually not that complex a script, and what I could show is a tutorial of running this through a loop, as opposed to having to do this, or you could try and program it through a range or a series to start, because it's not that complex. Anyhow, thanks for watching. If you want to know more, I will continue with this model. I will look at the Parthenon. I will try and make it as unique and fun as we go, and I will start to use things like over here in sets. One of my favorite tools for controlling geometries is the shift paths, which allows you through masks to grab whatever geometry. Actually, not the offset shift mask. That's not the one I like. It is the oh, which one do I like the most? Path Mapper, Math Tree, a split tree tool, which I like masking, and I'll show how to use that for geometry. Is probably the best tool for when we get into a box array or a square array or a grid. We can start to pull points when we start to consider the top view and what's necessary to think about these columns and changing them and selecting which ones we want. So I'll use that in the next one. Sorry for a little confusion. I may make these a little simpler if people do have an interest in watching these scripts be built. But let's go back to some pretty archetypal geometries, architectures, and see if we can't build them in Grasshopper, keeping the subtleties and complexities involved.